In today's short video, I'm going to show what I would do if I would troubleshoot the phono amp. Say, for example, if I didn't have any output at the phono amp. In this particular stereo receiver, the Marantz 2215B, it uses basically an IC for each channel, basically a little amplifier IC, and the signal comes in at pin 2 and it leaves at pin, looks like pin 6, and the same down here with the other little IC, same story. Now the function switch is over here. It's past this point, past the output. So even if I were to go ahead and put the function switch, for example, in the aux position, it wouldn't affect my output here. Also, the volume control is also further down the line, so if I were to play around with the volume control, that wouldn't affect my output either. Now I printed out the specs too, and we can see here it says input sensitivity 2.2 millivolts. So basically, for example, if I would feed in a 2.2 millivolt sine wave, for example, and I had the volume control turned all the way up, that means we would be putting out maximum output power at that time, and that would be 15 watts per channel. But if we come up here and it says input overload at 1 kilohertz, so we fed in a 1 kilohertz sine wave, this phono input unit can take 100 millivolts. Also, I have to point out, sometimes, like if the voltage coming in from a phono cartridge from your turntable or record player, a lot of times that has a really low output. Say, for example, it might be 4 millivolts or 5 millivolts, really low, and a really low level waveform, a really low level signal that's that low is really hard to work with. So what I do is basically I go ahead and use more than that. I might use 10 millivolts or, if possible, 20 millivolts, because I just want to go ahead and see what's coming out at the other end. Now we can see how I got things hooked up here. I have one of these adapter cables coming from my audio generator, and that's how I'm feeding the signal in. And that black cable there, that's coming from the audio generator, and that just plugs into this adapter. I think I got this adapter off of eBay, I believe. Now what I'm looking at here is the phono input left and right channel. This is this thicker cable here. It's a shielded cable. And I'm going to hook my oscilloscope probes across the left channel and the right channel. I have the power off now. In fact, I can trace the signal all the way up to the input of the phono board without using power, basically, without powering the unit up. Now I've got both of my probes hooked up, one for each channel. Now we can take a look at the waveforms I'm feeding in. Each channel is getting 20 millivolts peak to peak, or rather 10 millivolts per division, 10 millivolts per box, and it's a standard 1000 hertz signal. Again, I don't have a dummy load hooked up, and I'm just checking strictly the output from the phono amplifier. Now here's where the signal comes in from the phono jacks. This here, what I'm tapping on, is the phono amp board, and of course there's this white wire for one channel and the pinkish wire is for the other channel. So I'm going to hook up my oscilloscope probes to these pins here, and we can take a quick look at the signal. Now I have both probes hooked up across the input pins. I still don't have the power on yet. Now we can take a look at the waveforms here. So far so good. Now I have had it before, for example, that there's been a bad solder joint, or there's been a break in the, it's been a cable break. That can happen too. So that's why I'm starting from the very back from the input and working my way basically through the phono amp. Now I have the scope probes hooked up to the input pins of the phono amp, and it looked like here with the schematic I had, I think actually what I'm touching here with the pin I'm touching now with my chopstick, that was supposed to be the phono input, but on my particular amp section here with the actual physical layout, it's not that way, because I checked it with the scope and it wasn't correct for some reason. Either I have the wrong schematic, or it's just they just made a boo-boo or something. Anyways, that's possible to, to simply trace that. Now I'm going to go ahead and turn the unit on, and we'll go ahead and check the output pins, what's coming out of the phono amp. Now the unit is on. I have the scope across the output pins, which are pin 5 and pin 6, and we can take a look at the scope. Now here we can see the signal from the output pins of the phono amplifier, and if we notice here, it says here 500 millivolts, that's per division, so 2 divisions, so we've already got 1 volt, basically 1 volt for each channel, and we only had about 20 millivolts coming in, so that already tells you right there, there's a large degree of amplification, and so far the signal actually looks basically okay. Again, this is just a real basic checkout. Say for example, if you didn't have anything coming, it could be that for example the IC went bad, or you might have an open coupling capacitor, and then you would, for example, see nothing. Since there's not really too much on the board, you can always check the input voltages coming to the IC, and you can check the, for example, you can check the capacitors. Now what we're looking at here is the bottom of the phono amplifier board, and here we can see the pins of the IC. Just for example, what I'm pointing at now is the pin number 1, and pin number 1, if you're looking from the standing in front of the unit, would be the pin closest to you, and pin number 7 here would be toward the, that would basically be the pin furthest away from you, and pin number 7 is also the power supply pin basically. So if you're measuring the voltages here, you're going to have to be really careful. These are going to be, of course, DC voltages you're measuring, but you're still going to have to be careful. You don't want to short anything out. And what I like to do a lot of times, for example, I'll take like a stiff piece of wire, solder this onto the pins I want to measure, of course with the power off, and then hook up my meter and then turn the power back on. This is, admittedly, it's a time-consuming way of doing things, but you're more on the safe side. Now if we take a look at the schematic, we can see that each channel of the phono amp also has a coupling capacitor at the input and a coupling capacitor at the output, and these basically just, they'll let the sine wave or they'll let the music pass, but they will block any DC voltages, because we don't want any DC voltages getting into this circuit, which could upset this circuit and basically change things. And in order to check these, we just clip the scope on one side and at the input side, and then we clip it to the other side, and the waveform should be the same on both sides. If not, we might have a problem with this capacitor. We could also try to put another one in, basically in parallel with it, to bridge it with another one and see if that works. If not, but this, for example, this could be leaking DC, so what we would have to do is go ahead and unsolder one side and then bridge it with another capacitor. And then if we know the waveform has improved or looks like it should, then we know, for example, that this is bad. Of course, if there's nothing coming out on the other side here, then it's probably open, and well, then for example, you can go ahead and figure, well, just go ahead and replace it. And for the input here, they use a little blue tantalum capacitor. They use these because they have very low leakage, which I think is probably something you don't want happening when you're working with the real low levels of the phono amp. And at the output here, this seems to be like a 1 microfarad. I can't see it from behind the camera. Could be 20 or 50 volt. I'm not really sure because I can't see it from here. But anyways, this is not a tantalum capacitor, but a electrolytic capacitor. Now I'm going to check the signal coming into one of the input capacitors and then going out of it, and the signal should be the same. I have the power on now, and I should be getting about that same 20 millivolts input on both sides. This would be the other side. This here, I think this here is the other side of the capacitor, the side that's basically going into the IC. Now here's the signal going into the capacitor. Now I'm on the other side of that capacitor, the side going toward the input to the IC. Now here's the waveform of the other side of that capacitor, and it's basically the same as the input side, so everything's okay. This is the way it's supposed to look. I think this about completes this video. The good thing is with the stereo units, you can always use one channel and compare that to the other channel. Even if you don't have a schematic, the good channel will tell you what voltage to expect on the bad channel. Of course, if you do have a schematic or a service manual, that's a real big bonus. Of course, sometimes you do have cases like, for example, both sides might be out, and if you look at the power supply pin coming in, there might not be a voltage, and you check the other one, there might not be a voltage there too, so that will tell you, okay, maybe the problem's up with the power supply. And for example, say if voltage is off, let's say I think this is 2 volts, you could go ahead and start checking components around that area. I wouldn't immediately just go ahead and swap the ICs out, even, well, for one thing, like they're hard to find nowadays. I would go ahead and check the components first. I think this about, well, that about sums this video up. Thanks for watching.